This lesson is on work and non-conservative forces. These questions here are really similar to the conservation of energy questions that we did last week, except for, in this case, energy is going to be lost as you travel through the motion. So the energy before will not be equal to the energy after. The first thing this note talks about is work and non-conservative forces. It's not a big part of what we're eventually learning, but it is some terminology that's neat to understand. So you can see in the note, read it, and then I've got a little diagram here. Okay, if we were to push something up ramps as such, okay, and we were to try to find the work against gravity, okay, it's only the force V that's going in the direction of H for gravity. Okay, so it's only that force, okay, that component of the force for gravity that's going to be doing work. So if you were to just calculate the work against gravity, you just use Fg times H. Okay, so it's independent on the path. Okay, if I zigzag twice as much, it wouldn't make a difference. But if you're looking at the force of gravity, every motion of this is resisting friction, and friction is directly parallel to delta D, so all of this is going to be your work. Okay, so the non-conservative forces, like friction, is dependent on the path, and gravity is independent on the graph. Okay, these questions that we're going to do basically have three sets of questions, okay? And you start with these equations here where work is force times distance. Okay, the force is always going to be friction, maybe gravity sometimes. And work is change in energy. Energy before, after minus energy before. Okay, so in the first set of questions here, what's going to happen is you're going to know all about the energy before, you're going to know everything about the energy after, you're going to calculate the energy, and then once you find the energy, you divide the energy by delta D to get that force. There's a couple questions that are similar to that. The next type of question, okay, is one where you are looking for something in the energy after, either the height, the x value if it's hitting a spring, or the velocity. But you're learning something about the energy after. You know everything about the energy before, okay, and you've got the force and the delta D to find the work in between. Okay, I've got plus work here because that's the way the equation works. But in this case, because force and delta D are opposite, work is going to be negative. So you're going to get the energy after is going to be less than the energy before. So what you do, find your energy before, find your work, solve for the energy after, let that equal whatever energies there are, and solve for V and H. The last set of questions is similar to the previous. In this case, we're looking for something in the energy before, either the height, the x value, or the velocity. We know everything about the energy after. Again, we know everything about the work. Minus work here that ends up being a plus in most cases because work is negative. So you find your energy before using this equation. And then once you have it, let it equal your two energies and solve for either H or V. I hope this was helpful. Send me a message if you need further information. Thank you. Bye.